Guys, welcome back to Vectrex Academy. So, in the last class, we have been discussing about our first law of thermodynamics, and in this class, we will be discussing about the second law of thermodynamics. Okay, the second law mostly concentrates on two parts. One is entropy, other one is free energy. Okay, it's represented by delta S and this by delta G. Okay. Yeah, so in this video or in this lecture, we shall be solving this matrix matching where what is it saying? From the TS diagram of a reversible Carnot cycle engine, you need to find heat gained by the sink, work done per cycle, efficiency, and number of cycles required to illuminate 1000 bulbs of 200 watt each per second. Okay, first of all, in the last video lecture, I have been talking about enthalpy, right? Okay, what did I actually say? It's the total heat content at the constant pressure, right? But the thing is, uh, there are two types of reactions actually, spontaneous and non spontaneous. Okay, spontaneous, it's very simple. These reactions actually doesn't require any external force, they happen on their own. Like if you put what do we say if you put an ice cube uh, in at room temperature, then what happens? It automatically uh, then what happens? It automatically gets converted into water, where we aren't putting any external force. Whereas in case of non-spontaneous, it's opposite. You need to have some external force, or else it's not possible for you to do that reaction. Okay. Like if you want to send something like from lower potential to higher potential, then obviously you need to give some external force, because nature says that anything which happens always happens from higher potential to lower potential. So it's obviously not possible for us to send anything from lower potential to higher potential. So it's it's called as, those reactions are spontaneous reactions. So as the first law couldn't explain about the spontaneous and non-spontaneous reaction, during the second law, first attempt was made with enthalpy. Okay, what is this enthalpy say? Like, okay, if your delta H is negative, then it's exothermic, and if it is positive, then it's called as endothermic reaction. Okay, if it's exothermic, in the first attempt of spontaneous, in explaining the spontaneity of any reaction, if the enthalpy is negative or if the reaction is exothermic, they told that it would be a spontaneous reaction, and if it's an endothermic reaction, then it would be a non-spontaneous reaction. But there were so many flaws using enthalpy to discuss about spontaneity, which is again wrong, because there are some reactions where are uh, exothermic reactions are, what do we say, yeah, so exothermic reactions, they themselves can be spontaneous and they cannot be spontaneous at the same, like few are spontaneous, then other few can be either spontaneous or non-spontaneous. Okay, next next attempt was entropy. Okay, Here in this video I won't be discussing about free energy, uh, because free energy is like, basic definition of free energy is that it's the useful work. Okay, if you want any good question to like, if you want like the best concept clarity, then please work out on 2016 JEE Advanced question. It's like a very good question. Yeah. uh, so here what they told was dg equals to dh minus dts, or this is actual equation of uh, what do we say, uh, gives free energy. Okay, well, coming to entropy, what is entropy? Entropy is simply randomness or disorder. Measure of disorder. Or disorder. Okay, so in this again we are having delta s of system, delta s of surrounding, and delta s of universe. As we discussed in the previous video, universe is everything and system is the part which we are speaking about, and surroundings is everything except system. Okay, and delta s system plus delta s surroundings is equal to delta s of universe. Yeah, so when it actually had come on the discussion of spontaneity, if your system's uh, entropy is positive, then it was spontaneous. But if it's negative, then it's non-spontaneous. Which was the discussion made actually. And there were so many reactions which didn't follow this. Though you know that they are spontaneous, but you couldn't say that the entropy was negative or positive such. Okay. And finally they made a conclusion with free energy that if your free energy is negative, then it's a spontaneous reaction. If your free energy is positive, then it's a non-spontaneous reaction. Okay, these are the things, and this part actually succeeded very well. Using free energy, they could explain the spontaneity of most of the reactions. Like, I don't think there is any exception in explaining spontaneity with the help of free energy. Okay, and in future chapters we would be actually seeing about equilibrium. There you will be using this formula, and in case of electrochemistry you will be using this formula. Okay, here k is the equilibrium constant and E naught is the standard potential, and F is Faraday. 1 Faraday equals to 96500 coulombs, and N is number of electrons transferred or number of ions transferred. Okay, during the chemical reaction. Next one is again the most simple part. ds is integral dq by T. Okay, this is how entropy was defined. Okay, so now if you want to calculate entropy at a particular what do we say process, then how do we calculate? It's again easy. From the first law of thermodynamics, we got to know that dq equals to du minus dw, right? This was what known to us, and we know that du is ncv dt, and we know that dw is minus pdv, and we also know that from ideal gas equation pv equals to nrt, right? So here you're just gonna replace p with nrt by v. Then your dw is minus nrt dv by v, right? Just substitute them in the just substitute these values in the equation of ds. Okay, so while integrating ds s1 to s2, it's simply dq by t, right, which is integral du minus dw by t, which is again the integral of ncv dt by t minus of minus nrt by tv dv. Okay, this is again it becomes plus. Now I think, yeah, and we can cancel the temperature here. Now it's very easy. Okay, we know that for a particular gas n is given and cv is given, so here it's only dependent on temperature, and here we know that n is given and r is given, so it's only dependent on volume. Then you can take out n and cv from the first integral part and n and r from the second integral part, and what are you left with? This, if you integrate the ds, you get s1 minus s2 or s2 minus s1, which is delta s. Then here you get ncv ln t2 by t1 plus nr ln v2 by v1. Okay, this is the formula of entropy of system, right? Next, let us look at each and every process. So if the process is isothermal, then we know that p1 v1 equals to p2 v2, and we also know that temperature is constant, right? Just substitute it here. Then what will you get? Delta s equals to ncv ln 1 plus nr ln v2 by v1, right? Why is it ln 1? Because temperatures both are same. It's as it's an isothermal process. We are assuming if it's an isothermal process, then what would happen to our entropy? That's what we are gonna find out here now. Okay. So if you put your temperature as constant, then this will be ln 1. Ln 1 is again 0, right? This part is 0. Then your delta s is nr ln v2 by v1. Okay, this is for isothermal. Now let us look at Isochoric. At isochoric, we know that volume is constant, and we know that P by T is equals to P1 by T1 equals to P2 by T2. And yeah, the very important part, as we wrote in work, similarly we are going to write it here as well. Okay, and next here again we will just substitute that, then you will get NCV ln T2 by T1 plus 0. So because again the simpler reason, if volume is constant then it's going to be ln 1, and value of ln 1 is 0. Okay, and the most important process when we speak about entropy is adiabatic process. Why is adiabatic process that important? Because we gave the definition as, right? Okay, so if your dq is 0, in case of your adiabatic, your dq becomes 0, right? If your dq becomes 0, then obviously your entropy becomes 0. So this is called as isoentropic process. Okay, so the entropy remains constant throughout this one. These are the basic ideas which will be required for solving our question, the matrix match. Okay, and the most important thing is what the second law says is that um, you know we do know that heat can it travels only from hot body to cold body. That's what we know that, as it's the basic principle of our science which we studied from the lower classes. And yes, it's obviously correct. Like whatever we do we cannot change it because it's the law. And there's a scientist called as Carnot. What he actually did was to calculate the efficiency. If this is your A point, this is your B point, then this is your C point, this is your D point, and okay, he took a cyclic uh, process, and he tried to calculate the efficiency. While calculating it, he got one interesting equation, that is T2 minus T1 by, I think I am wrong, let me check it. Yeah, so he told that efficiency is like work by total heat. Okay, if you want to calculate the percentage, it's just you multiply it into 100. Okay. Mm. And while solving it, actually, while you solve this, like efficiency equals to work by total heat, you get to this equation, 1 minus T2 by T1. This is the equation which you get. Okay, so he just took that, AB and CD as isothermal, and BC and DA as adiabatic. Yeah, just look at what is compression and what is expansion, then you'll get to know. Okay, and always remember, in case of expansion, your work is always negative, and in case of compression, your work is positive. Simple reason. When you substitute your uh, equation of volume, oh sorry, when you substitute your volume in work, which is W equals to minus nRT ln V2 by V1. So if it's compression, then your long term will be negative. I mean, the output of long term will be negative and work will be positive. Similarly with expansion. Okay. So, uh, with this, let me introduce to two terms, source and sink. What does source mean and what does sink mean? Source is something which gives heat, and sink is something which takes heat, or heat flows to sink. Okay, now uh, let me just take this our question. Uh, yeah, so in this question, they just told us to calculate the heat gained by the sink. That means heat absorber is basically your sink. Okay, work done per cycle, efficiency. Okay, all these things. First, the very most important thing when you're given graphs like this would become actually uh, the very important thing becomes identification of process. Okay, if you can gather the information according to the process, whether it if it's like, see, all processes are polytropic process. If they are not polytropic process, see, like isothermal process, adiabatic process, isochoric process, all these processes are simply your subset of polytropic process. Okay, now if temperature is constant, we know that it's isothermal. If volume is constant, we know that it's isochoric. If pressure is constant, then we know that it's isobar. Yeah, and if the heat is constant, then we know that it's adiabatic. If again it's an isoenthalpic, then we know that it's again a temperature will be constant. If it's isoentropic, then we know that dq is 0, right? So first, anytime, while while solving this thermodynamics question, while looking at graph, first identify the process, which makes your work like so easy that you can actually complete the question within very less time. Okay, so here, while solving this question, uh, see, from 1 to 2, it's basically temperature is constant, right? Okay, if temperature is constant, then it's isothermal, and from 2 to 3, entropy is constant, then it's an adiabatic. From again 3 to 4, temperature is constant, which is again isothermal. And 4 to 1, entropy is constant, which is again adiabatic. Okay, that's it. Now finding the heat, which is like the most important part. Okay, you know that here the heat is constant and dq will be 0. Similarly here as well. Okay, in case of isothermal, you just simply uh, you have the equation as dq equals to ds into t, because temperature is constant here, this is changing. So the change in heat is this, right? From process 1 to 2, what happened is the temperature is 800 Kelvin and change is 500 minus 400, that is 100, right? So Q from 1 to 2 is 100 into 800, that is 80 kilojoule. Okay, similarly from 3 to 4, it's minus of minus 100 into 400, which is minus 40 kilojoule. That means it's basically the heat absorbed by the sink. Okay, and here this both being adiabatic, 4 to 1 and 2 to 3, here dq is 0. Okay, both the cases. Then you can obviously calculate q here, which remains same here, and q here, which remains same here. Okay, that's not an issue. First we shall be calculating our efficiency, percentage of efficiency, which is given by the form. Okay, 1 minus 400 by 800. So efficiency is given by half. With this you can match that your efficiency is 3 matches to q. Sorry, 3 matches to s percentage. Okay, yes, yeah. So from this you can eliminate this, and from here you can eliminate this. Next thing is we are gonna solve for our, so to calculate work done, percentage efficiency is always work done by total heat, and this is your positive heat. Okay, here you are gonna only use your positive heat, that means here you will be just using your 80 kilojoules, not the minus 40 kilojoules. That's basically what the sink has absorbed, while the process was going on. Sink is the one which absorbs the heat, and this is actually what your sink has been observing. So your one actually matches with R. Okay, so this is again overruled. and this is your incorrect option, because easily you can say, because it's mod w, modulus is always positive. So the next one is uh, half equals to w by q. So with this you can say that your w is 40 kilojoules. Okay. So this is 2 and this is p. End of the matrix. And if number of cycles required to illuminate 1000 bulbs of 200 watt per second. So here this says that in the fourth question, 1000 number of cycles required for 1000 bulbs of 200 watt each per second, right? So your 1000 bulbs produce the power of this much, right? If I'm not wrong, then it's 1 2 3 4 5. Yeah, and this is what the this is, right? And your total work is 40 kilojoules. So just divide it by so number of cycles will be this total by the total work. So your value of n is 5. Yeah, that's it, guys. So your value of, so 4 will match with q and 3 will match with s. So yeah, that's it for today's lecture.